Hello and welcome. This is sets video number 13 and we are going to find out how do we solve problems involving sets. So in this video we are going to particularly take a look at how do we solve these type of questions. Is the following set a null set? Where the set is defined as x is an element that is a natural number and also 2x plus 6 equals 0. Similarly, is this a finite set? Set contains element x where x is a natural number, x is a prime number, and x also satisfies this condition. And finally, questions like this is the following set a finite infinite set? Another example. So here set A is defined as a set of natural numbers which are divisible by 5. Now if you want to follow along and practice on your own these type of questions, simply go to www.risingpearl.com, hover over from the top menu to Class-11-Math and choose Sets, Problem Sets. It is going to show you a list of all problem sets on the topic sets and click on Problem Sets number 2. Or you can simply click on this link here. I'm going to also provide this link on the top right hand side corner of this video and in the description box below. Let's get on with how do we solve these type of questions. So here set A is defined as it contains element x is a natural number, and also 2x plus 6 is equal to 0. Now we know what are natural numbers. Natural number collection is simply represented by uppercase letter n, and these numbers, number 1, number 2, number 3, number 4, so on and so forth. This collection of numbers, we know they are natural numbers. So x has to satisfy this. Also, x has to satisfy this condition. So how do we find out? We have to solve for x. So let's do that. So we have 2x plus 6 equals 0. So we will take 6 on the other side of the equality sign. So we will get 2x equals minus 6. Now we will divide both sides by 2. And here 2 and 2 will cancel out. So we will get x equals, here this will be 3, I should say minus 3. So x is equal to minus 3. So we see that the value of x is minus 3, but x has to be a natural number, and these are natural numbers. So negative numbers are not natural numbers. So we say that our set A actually has no elements, right? Because the value of x, the x has to satisfy this and x has to satisfy this. But there are no common values that satisfy both the condition, and hence we have x which is a null set. It does not contain any elements. Let's take a look at a second question. Here set B is defined as such a set that contains element x where x is a natural number, x is a prime number, and x is in this range. So let's first find out the range. So x is greater than 7. That means x will start from 8, then x can be 9, x can be 10. Can x be 11? No, but because x has to be less than 11. So x is greater than 7 and x is less than 11. So x can be any of these values. Now, are these prime numbers? Remember that now x also has to satisfy these three conditions. It is a natural number. They are all natural number. But x is also a prime number. This is not a prime number. This is not a prime number. This is not a prime number. So we say that here again, set B does not contain any element. So this is actually a null set. Now let's take a look at a third question. So the solution set for the equation 3x plus 4 equals 0. So 3x plus 4 equals 0. So we can simply solve here for x. So we have 3x plus 4 equal to 0. So get 4 on the other side. So we are going to get 3x equals minus 4. We will simply divide both sides by 3, and 3 will cancel out, and we will see x equals minus 4 divided by 3. So this set contains one element which is minus 4 by 3. So this is not a null set. It is actually a singleton set. It contains one element. Alright, now let's take a look at some of these questions, finite sets or infinite sets. So here set C is defined as it contains element x is a natural number, and x less than 3. So now if we write natural numbers, they are number 1, number 2, number 3, and so on and so forth, but x is less than 3. So 3 we cannot write. So our set C, I should say, has these two elements, and hence this is actually a finite set. Now let's take a look at this next question. Here set D is defined as such a set that contains x, it contains element x is a natural number, x is a prime number, and x is in this range. We have seen this question a little bit ago, and we have seen that here we realize that set D is actually a null set. Now remember, a null set contains how many elements? So number of elements in a null set is how many? It is 0. Is 0 finite count or infinite count? 0 actually is a finite count. So keep this in mind, that if a set is a null set, it is a finite set. So we say that the set D is a finite set. Even though it is a null set, but it is a finite set. Very important point to keep in mind. Let's move on to the next question. Here our set is E that contains element x, where x is a point on a given line AB. So this is a question of set and geometry. So let's draw any line AB. So let's draw something like maybe a line like this. Let's say this is our line AB. Now x is any point on this given line. So this can be x, this will be x, this will be x, this will be x. All of these points are x. Now we know what is the definition of a line. A line is represented by arrows on both ends, which basically signify the fact that the line extends infinitely on both directions. So a line will have infinitely many points. So this is an example of an infinite set. So here E is an infinite set. Now what about this question here? So set F is a set of natural numbers which are divisible by 5. So what natural numbers are divisible by 5? So well, the number 5 is divisible by 5. 10, basically we have to write multiples of 5, right? 5, 10, 15, 20, 25, and so on and so forth. So as you can see, so this is going to be our set F, and it will go on forever. So this is an example of actually an infinite set. Maybe let's take a look at one last question before we wrap up this video. So here again, this is a sets and geometry question. So set of lines parallel to x-axis. So let's draw a coordinate plane. So we can draw a x-axis like this, and we can draw a y-axis like this. It is just hard to draw lines in a freehand mode. So let's say this is our x-axis and this is a y-axis. So y, y dash, and this is x, x dash. So lines parallel to x-axis will be lines like, let's say this is y equals 1, y equals 2. So we can draw a line like this. This line, let's say equation of this line is y equals 1. And this line is y equals 2. So similarly, we can imagine a line like this, which is basically, let's say y equals maybe minus 3. So how many lines like this can we draw? Well, as you can guess, we can draw infinitely many lines, and all these lines are parallel to our x-axis. So we say that this set contains infinitely many elements, and so this is an example of an infinite set. So again, if you want to solve questions like these, please head over to risingpearl.com, and from the top menu choose Class 11 Math, Sets, Problem Sets, and select problem set number 2.